Hello and welcome everyone. Thank you for joining us today for our webinar titled How to Be Successful Right Away in Your New Data Science Role. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Tom Ott is a Senior Customer Solutions Engineer at H2O.ai. And before I hand it over to Tom, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Tom.
Thank you, Patrick. And well, good afternoon, good morning, good wherever you are. I know that in this global world, and especially things that have gone on with COVID right now, we've become very, very distributed. So there's been a lot of great stuff happening online, and I'm glad that you're here today. I'm going to talk a little bit about how to be successful right away in your new data science role. And some of the answers may not necessarily be very intuitive as what you thought, but there is an intuitive nature to that. So let me just kind of get a little bit started here and talk a little bit about how we're going to frame our talk today. I'm going to do a quick little introduction about myself. I'm going to talk a little bit about data scientists. Are they born or are they made? And then talk about the pathways to success as far as from what I've learned being in the trenches. And then we're probably going to talk a little bit about how H2O can help you on that journey, and then open it up to some Q&A. So let's talk a little bit about who I am. How did I get into this data science field? I am definitely not a data scientist that was born in the classical sense, and we'll talk more about that in a few minutes. I kind of fell into it. I have a background in civil engineering. I am a licensed professional engineer in several states across the United States. And I didn't find out about quote unquote data science or machine learning until I went and got my MBA in technology. And that was in the early 2000s. And I took a course called Data Mining for Managers. Now, I know I'm kind of dating myself here using the term data mining, but really this was at the time even before Hadoop was around. And data was stored in databases or flat files or something along the line. And what I enjoyed the fact that I can use statistical methods to find patterns in data. I thought, how cool was that? So that kind of led me down this rabbit hole to what eventually became machine learning and data science. And then in 2014, I left the engineering field. I worked in transportation for over 20 years into the startup world, and into a machine learning data science startup world. And currently, I am now at H2O, where I am a senior solutions engineer. And normally, what I do is I utilize my curiosity as an engineer to help customers and prospects put models into production or help them transform their companies into AI companies. So that's a little bit about who I am. And I think that if you just kind of remember that a little bit, where I say, I kind of fell into it, this will help frame this next part of the discussion. So, are data scientists made or born? The image that you see here on the left of the modern data scientist is something I'm sure many of you have seen before, right? It talks about, what a data scientist, they typically have a solid foundation in math or STEM-related fields. They know how to code, SQL, Python, R, Java, what name you. And then, of course, they're awesome visualization wizards, right? They can paint a story with pictures. And all of that is true, but perhaps the one that I want to kind of talk a little bit more on is this last part. It's the domain knowledge, and it's the soft skills, right? So domain knowledge could be pretty easy to get to if you're working in a field in finance or insurance. You kind of know about what's going on in those fields. But the softer skills, let's come back here for a second. The softer skills are really what it's about being able to communicate, to understand why you're doing the things you're doing. So, but that also kind of leads me into this other idea of what are data scientists themselves made or born, right? Because I fell kind of into it, right? So, is there a path for a born or made data scientist? And let's just take a look at that here for a second. Classically trained data scientists, or what I'd like to call them, are typically what I say born data scientists. And these are people that come from a physics background, maybe a math background, a computer science background. They went to university for it. They may have PhDs in one of these or more. They're the ones that have had to deal with, and I'll give you the example for physicists. They're typically very good trained data scientists. They've had to deal with things of uncertainty, and they've had to deal with how to actually make predictions without not knowing everything, right? The classic example is the Higgs boson. It was predicted to exist within a certain energy range, and our sensors weren't able to detect it until recently. And sure enough, the absence of having data was able to allow us to make these predictions, and sure enough, it was proven, right? So those are the typically born data scientists. They come from that very, very rigorous background. Me, and I'd like to think maybe a lot of people on this call, are kind of the made data scientists. It's need-based. The company says, well, we're moving out of, we're moving from flat files to databases, and we want to be able to use something more than linear regression to make predictions, right? Those are the ones who kind of fell into the field. They started, learning maybe Python or maybe R to do visualizations, or maybe in Python to do automations for reconciling spreadsheets and maybe automatically printing out, weights or other types of functions. So those are the ones that are typically kind of fell into it, and they kind of maybe take a Udemy course, or they take something along the line to get to brush up and to really learn a lot of these skills, right? And out of all of these data scientists, out of all of them, normally what really is a big driver of the success, when I come back to this again, are the softer skills: curiosity, learning, passion, right? So once either you're a born data scientist or you're a made data scientist, once you're in the data science field, I consider that as the starting line for your career, the starting line of how far you want to go. And how far you want to go, how successful you be, is going to be tied, in my opinion, toward the softer skills. So let's talk a little bit about some of those softer skills and building that pathway to success. Recently, and I think this was timely for my talk, somebody on my Twitter shared this particular article from Australia, and it was about a woman, Rosemary Barnes, who had studied engineering, art, and philosophy. And it was an interesting interview or discussion about, is STEM really where we need to focus on, right? Are we minting all these data scientists and engineers? Do we need to make sure they have all the technical aspects, right? All focused on job readiness. And there is some truth to that, of course, right? You need to be able to know how to do this job as a data scientist. You need to know what a good area under the curve is. You need to know, how an experiment is set up properly. You need to understand things like data leakage and so forth. But one thing that in the article highlights is that, in her opinion, the arts and philosophy portion of her education, right, which is not necessarily the job readiness part, really helped her apply critical thinking vision to her work, right? It kind of helped her shape the problem, make it understand the problem, like, is there, reason for, should we actually do this, those type of things, right? So necessarily it's always a function and form. It's not function versus form, right? Or function in this case, but it's really a combination of function and form. And I found this particular article to be actually quite insightful to the sense that math and science are all part of the equation for longer success, in my mind, for building the success. So how can we do this, right? What are some of the key pathways to success? And I have them down to 6 pieces. I call them really your work matters, right? Does your work align with business problems? Your domain will dictate your tools that you use. No-code platforms do have value. Keeping the option to code is always important. And of course, staying on top of the new trends. So let's take a second here and drill down into a couple more of these. I'll kind of elaborate on them here. So your work matters, but you need to ask how it matters. You're a new data scientist. You just got a new job, hopefully a new career at some firm, and you're going to be doing some projects. You're going to be doing something, right? And I always start with all my with all my mentees. I used to have a lot of mentors, which have guided me through my career, and they're always very important to have. but now I act as mentees to some. And I always tell my mentees that you need to manage your career, right? It's always going to be number one. So always look out as you're building your success in data science, as you go from maybe being a junior data scientist to a senior data scientist, or even a startup rock star data scientist or whatever. You have to always kind of think about managing your career, right? Ask yourself, do the projects you work on align with your goals, your professional goals? It might even be, questions that you need to ask yourself, like, do these projects I'm working on align with my ethics? Right? There's been things in the marketplace about various cloud providers, where data scientists are concerned about what they're doing, per se, right? There may be an ethical reason for it. So you have to, as part of managing your career, you have to also think about how the projects you work on will align with your goals, whatever they may be. Of course, big believer that, you always have to be learning. Once you finish your engagements, your projects that you work on, will you actually come out of them with new skills? Did you do the research on switching, let's just say, from linear regression to XGBoost? Did you, use that and squeeze out more performance out of it? Did you learn about hyperparameter tuning, the various, tree algorithms and so forth? Are all these different things that you're working on building internally for you to actually grow as a data scientist, right? And perhaps one of the most important things, which kind of ties into the managing careers and all this, is how do you feel in the morning, right? This is a really strange question to ask. How do you feel in the morning when you get up? When you get up in the morning, are you ready to go to work? Are you ready to take on the day? Are you ready to go and, build some new apps? Are you ready to go solve a problem? Are you ready to really squeeze out more performance in your models? Are you ready to learn more about the project you're working on, or really, shaping the direction of it to come, right? So how you feel in the morning, to me, is also equally important to help you judge how successful you're going to be. If you're just doing this just to get a paycheck, you might wake up one day to say, I don't know if I want to go to work. This is going to be another day writing some code, or another day, fiddling to some some silly experiment that I really don't care about, right? Once you get to that point, you need to go to that first bullet, right? And you need to go back and figure out how to manage your career again. Great stuff. So, what's the next one? Your work needs to align with the business problems. This is typically overlooked by a lot of data scientists, junior data scientists, and even some senior data scientists. A lot of them look at data science as being a scientist and doing experiments. And this is great if you're in the research phase, right? You're working with a lot of unknowns and so forth. But the chances are that you're going to be working for a corporation that is selling toothbrushes, or video, like say Netflix or something like that, or working for a finance company, Goldman Sachs or whoever, right? You're going to have some sort of business-related problem that the line of business manager comes to you and says, Tom, we need to increase revenue, or we have this problem. My mandate from upper level management is to cut costs, or to save our customers from churning, right? And a lot of times these LOBs, these line of business managers, will have very, very nebulous goals. They don't know how to translate their business ask into the technical speak or the technical requirements that you will know how to do, right? So I'm going to kind of just jump ahead here, where I'm going to talk about bridging the gap between technology and business. But this is where your success is going to really be driven, is how well you can bridge that gap between the business ask and the technical speak or the technical requirements, right? Building that bridge. And typically the way you understand that would be through a business performance indicator. You'll measure your success based on how well you're actually performing, whether and typically it's equated to dollar bills and stuff like that, right? So the business performance indicator, the bridging of the technology gap, or business and technology gap, right, is all very important. But going back to that first item that I talked about managing your career and understanding, right, and all those different things, if your work doesn't have a direct impact to the company, then typically it's a waste of time. It's just an experiment. It's just a fun thing to do. It really is not driving any underlying value. And you should ask yourself the question is that if this project you're working on or you're about to work on, how is it going to be tied to the business problem and how much of an impact is it going to do, right? And it could be something, impacts could be measured in different ways, not just money, but maybe you're looking for conservation. And you might be saying, well, a work I'm going to do may help the breeding of elephants, rise in Africa or something like that, right? So that could also be another indicator or another direct impact and so forth, right? So all this eventually comes down to having you learn to ask the right business questions for the task at hand. Okay, let's go on to the third one. Your domain will dictate your tools. If you're in the healthcare industry, you might use different types of algorithms. You might use different types of methods than if you were in the finance space, right? And typically, the open source software will really give you a head start here. A lot of times, and I come to find is just about everywhere in every industry, open source has wormed its way into that industry. And typically, open source is the right path, right? That doesn't necessarily mean that closed source doesn't have its benefits as well, too, of course. But you have to kind of keep an eye on when you're picking these tools to help you achieve the success of your project or whatever you're working on, is you have to kind of think about what tools are going to be easy to scale. Going back to what I talked about in the previous slide, if you don't have a direct impact on what you're working on, right, it's really kind of a waste of time. That kind of has another set of expansion here when I talk about production. If you build a model, hypothetically, let's just say you started writing some code and you took a sample of a data set, and then you write it, you test it, and then you scale it up to a Hadoop cluster. That's great, and you'll get the results. But how do you actually put that model into production, right? You're not going to sit there and every day and hit the run button. You're going to want to try to automate things, right? So you need to kind of look at tools that will help you scale and put things into production in a very easy way. And that's kind of thinking with the end in mind, so to speak, which is something from the Franklin Covey type of way of looking at it. Do you understand what the problem is that you're working on? You've now bridged the gap between the business and technology, and now you're looking to say, okay, well, I'm working on a very high impact project. What am I going to do with it at the end? Am I just going to hand them a report, or is this going to be put in production where every day the company will get value out of it? So you need to kind of think about those different things. You need to kind of think about setting yourself up for your technical success as well as your business success. And part of all this also, the domain and your tools, is really how quickly you can get to market. And that's that production part, right? How quickly can you iterate and build your models and get to a model in production? Time to market really matters, especially in today's day and age where things are happening and changing so quickly. And really, it's a matter of days or weeks sometimes between success or failure. All right, let's look at the fourth one. No-code platforms, they have their value. So a lot of times the data scientists will say, well, if I can't see the code, I really don't want to deal with it, right? Okay, they have a valid point. But in this case, sometimes there's a lot of great platforms out there that are coming out. Like if you look at any of the cloud providers, they have some sort of AutoML. If you look at our H2O3 open source, and we'll touch a little bit base on that later, we've always provided an open source. You can look at the code for the AutoML type of thing. You can do things that have like a no-code approach, and as well as our driverless AI platform, which is completely GUI driven, as well as also you can run clients on it. But yes, so you definitely want to look at no-code platforms as a way to speed up your work, right? To do benchmarking, to say, I have a bunch of use cases, I have a bunch of data sets. Let me put them in. Let me put them into the no-code platform. Let it run. Let it optimize for log loss or root mean squared error or something like that. And let me see if I can work through these use cases and see which ones have signal in the noise. And this is important because then you can quickly focus on the ones that do have signal, right? And discard the ones that are noisy, right? Because let's face it, yes, we can do a lot with computers these days, but if we can figure out ways to speed up the standard routine stuff like feature engineering, hyperparameter tuning, model bake-offs, trying different algorithms, and so forth, and all these different things, we can iterate and get to the end product faster. And that is actually very valuable because time, right, as I said, time to market matters. Time matters. Time is not a renewable resource. No matter how much we like to believe it is not a renewable resource. So getting to the end result faster and evaluating it and quickly making the decision whether or not this will work or not work is important. Okay? So let's get on to the next one. Keeping the code option, or keeping the option to code. No matter what you choose to work with in your career, you should always definitely have the ability to code. I think that this allows you to build custom things, right? It allows you to iterate. It allows you to stay also on top of the market as well rather quickly. Things like Python and R, Java or C++, depending on what your domain is, right? You want to be able to extend some of these abilities, some of these platforms with APIs or clients. And typically, if you focus in the open source world, right, you will typically be doing a lot of coding in that sense. So this is always a good thing to have. Now, the last thing I want to talk about on building your steps to success here is really staying on top of new trends. And I think that as a data scientist, you can't just graduate from college or take a course and get a certificate or get a degree and then coast your way into retirement, right? This industry is fast moving, and there's always going to be some new methods, and there's always going to be some new algorithms that are coming out every year. Deep learning right now, right, is a very, very popular new set of methods, and that has opened up the application to really some advanced machine learning, NLP type of problems. And it has really opened up a lot of visual image recognition and so forth, right? But with that comes some very complex type of algorithms, deep learning algorithms, whether they're convolutional or recurrent or long short-term memory ones. There's different algorithms that are going to have to be applied to different types of use cases. And understanding what algorithms to use and how to use them and so forth are always going to be important. So you're always going to be needing to brush up and to learn on how to do these different things, right? So always be learning and never stop learning, which is great. So how can H2O help you on this journey? I've mentioned a couple things before, especially our open source. I've also mentioned our driverless in passing, but I want to kind of talk a little bit about the four main products that we have here at H2O that kind of will help you along your journey to either, depending on where you are in the organization or what you're doing in the organization, that could help you, speed up and get to your results quicker. And the first one, and we're going to show just a quick little demo of this a little bit later on, is our product called Q. Now, Q is really meant for the business analysts. Those are the consumers of this product. And we really focus on that top layer, in the middle layer here, actually, and bottom layer, pardon me, is we let data scientists create AI apps, right? We have some in a store that you can download and use and apply your data set, right? But the whole idea behind that is that we, data scientists, can create these applications for a business analyst or other members of the business to use. And this is actually better than the standard BI type of world, where BI really is looking at data that happened in the past and visualizing that. Now you're actually beginning to use the power of AI to make forecasts and to do, unique things like, use deep learning before, NLP and things like that, where the business analyst can tie it to current data, current transactional data or new data that came in, and then apply the AI algorithms to it and actually get some new visualizations and actually be able to see where they're going, where they can actually make predictions as opposed to reviewing things in the past, right? So that's where Q really comes in, and it really sets the data scientist into more of a, building something for consumption at the very end of the pipeline there. Now, it works in a code and no code environment, but let's just talk a little bit about where the data scientist will typically live, right? And so a data scientist using an H2O type of product like Driverless AI or even the H2O3 platform, the open source platform, will typically spend all their time here. They'll be iterating, they'll be building models. We have products like sparkling water if you're working on a Spark cluster. We have Driverless AI, which is our automated commercial tool, right? And the beauty on all these products is that, yes, Driverless has a no-code interface, but you can code in Python or R. If you're using H2O3, you can do the same thing. It has a Python API and an R API. You can bring your own recipes, right? You can bring your own code and you can do different things with it. And where we focus on for all those products, whether it's open source or closed source, is that ease to put in production, right? Going back to where I said before about, thinking ahead for the production, right? Thinking about going from your experiment, building your experiment, saying Driverless AI, finding that signal in the noise quickly, and then actually trying to put into production. Well, how do you actually do that, right? So in our open source, we have something called the Mojo, which is a Java artifact, super simple to put in production. And then for Driverless, we come in multiple flavors. It comes in as a C++ scoring pipeline, which you can put into some other cloud provider. It comes with a Python scoring pipeline, and as well as the Java Mojo as well too. And there's some other ways to kind of take this model and quickly put it into production through REST servers. If you're running Snowflake, you can definitely plug it into Snowflake. Or if you're doing like in-database scoring with the standard Oracles of the world and Teradatas and so forth, right? So there's many multiple deployment options when it comes to these Mojos type of work here. So, and then the very last one is kind of a product that deals with handling those models in production, and that's our Model Ops product. And here's once you've created that scoring pipeline, whether it came from Driverless or from H2O3, you, with a one-click deploy or a simple push, you put it into Model Ops, and then you'll help monitor it. You'll deploy it. You'll spin it up into a Kubernetes pod, and then you can scale from that way, and you can quickly start scoring. And we'll do a quick demo of that here in a few minutes. So once again, let's just kind of look at the overall platform, starting building itself all the way up from the H2O open source. We have Q, we have Driverless, and then of course the Model Ops, all being supported by the open source platform. All right, so now it's time for demo time. I'm going to pause here for a second, and I'm going to share my screen and start thinking of some questions as we go through this, because after this demo, we're going to do a Q&A session here. Okay. And let's share now. Excellent. So I'm going to jump over here first, and hopefully you should be seeing a Jupyter notebook.
Yes,
and this is the open source. Perfect. This is the open source H2O3. Python API, R API, it is Java-based, right? So it scales really easily on Hadoop. H2O3 was built to scale on large data or small data. In this case, it's running on my little Mac computer, right? And it allows you to have access to these very powerful, highly scalable algorithms across a Hadoop node, across your multiple nodes. And today what we're going to do is we're going to just kind of look at it a little bit, and we're going to actually pick out H2O3 AutoML, which is going to be different than our Driverless, which I'll show in a minute. But if you're good at either coding in R or Python, in this case, I prefer Python, you just call out your various libraries. You start up your cluster here, right, by doing a simple initialization call. You load your data. It could come from S3 or Hive or wherever, or even from a flat file, from a CSV file. And then you do the standard stuff that a data scientist would do, right? You inspect the data. You might do some anomaly detection where we use one of our new algorithms, isolation forest. You might then append the data set with a new column, in this case mean length for the anomalies. Maybe then you do some conversions, right? So you do all this work on the cluster, right? So you're talking about big data here. and then you create something that has a yes/no column, and then you're going to put this into something called H2O3 AutoML. And this is the cool part. It's really just a simple 2 lines of code, right? I initialize my AutoML completely here, and I tell it I want to have a maximum set of 4 models. It then trains the model, and then it creates a leaderboard. Right? Normally what happens here is that if you let it run for longer, 10, 20 models, or maybe for several hours, it'll start doing automatic hyperparameter tuning using the grid approach. And then the cool part about all this is that at the very end, it creates stacked ensembles. It creates 2 types of stacked ensembles. One is a best of the family, which looks at what are the best performing family of algorithms. In this case, it looks like XGBoost seems to be the ones that perform quite well. So it creates a stacked ensemble of them. Or it just takes all the models that you were trying out and builds one stacked ensemble. And that's what we're going to kind of inspect over here today, right? So we can look at the leader for the automatic machine learning, H2O3 here. We can see that log loss was pretty good. Our area under the curve was pretty good. Okay, fine. We can make some predictions on this, right? And this is all done in the beauty of your favorite IDE, right? Whether it's either RStudio or in this case, Jupyter for me. And you can quickly evaluate the models and get, like I said, get to that signal in the noise really fast, right? But then there's so much other things that you can do with it. You can extract out the information. You can do different things like MLI, machine learning interpretability. We have something called auto documentation. Auto documentation, where you can actually automatically generate a report from the actual experiment right off the bat, which is a really powerful thing. But the machine learning interpretability part, which we have now baked into H2O3, comes with distributed random forest, comes with XGBoost, and it comes with GVM. And you can quickly come here, and let's go actually drill down here. You can quickly visualize the effects of a data set with Shapley values. You can see where the change is happening. And all that explainability is really important because we know that the statistical measures that we use to evaluate the model, like area under the curve or log loss, really just paints one picture. It just says, okay, the model generalized pretty well here, and this is how well it did. But the MLI portion, the explainability, helps us build trust in the model that it's actually making the predictions that we expect it to make, right? So this is an important thing. So this can all be done completely in our open source product here called H2O3. Okay. Now, let's actually take a look at another product, the other first product, which was which was Q. Q is an interesting product, which is really built by data scientists, right, to create these apps, to create these app stores, right, to allow you, the end user, a business analyst, to actually begin to use the power of AI, right? So we have a lot of data scientists and a lot of sales engineers and other people building these apps. Some are, related to optical character recognition, some are churn, some are related to COVID. And I think the one that we're going to look at today is really about birdsong recognition, which is actually pretty cool, which uses audio mining, right, to be able to try to make predictions on what type of bird that we're listening to, right? So we can come here quickly, and now this was built by one of our data scientists that likes to do birding, and we can quickly come here and we can do some visualizations, and we can see that, okay, the American redstart tends to live in this general area here. These are the song signatures of it, right, and so forth. And let's actually try to upload an MP3 here. And try to see what type of MP3 it is. I happen to know what it is actually, but we'll come over here. Now we can actually upload a WAV file or an MP3 file, and we can have it automatically use the model that's built in the back here to make the prediction. And so we can look over here, and let's see if we can actually see, and it says it predicts that it's actually a northern cardinal, right? So we can come over here and we can quickly look and see what the northern cardinal looks like in this particular case, right? So this is really the Q product that allows us to actually build these different apps, and they could be anything that your mind or anything that you want to desire, you can create, and you can make it available for your end business analyst, which is a very powerful product that is currently being from now. I believe it's in this quarter or the next quarter. So we are definitely look for that on the horizon. So that's Q. So we talked H2O3 and we talked Q. Now, let's actually get into the cool part, the driverless AI and the model. So driverless AI, and let's go load it up here from our platform. And this is completely GUI based, right? You can use it all in a GUI, but we also have the clients for R and Python. So you can interact with driverless completely from a command line, completely from your Jupyter notebook or wherever you have it, right? This allows those data scientists to have the no code and the code option all at once, which makes it a very powerful thing, which allows a lot of data scientists to overcome their hesitation with the whole black boxy nature of a lot of these AutoML tools. Driverless was specifically built by data scientists for data scientists, and there really is no black box nature behind it. There's a lot of different information exposed in so many different ways that you can get to, and you can feel comfortable using something like this to iterate quickly over your various use cases. So we're just going to kind of just build a really quick model and show you how easy it is. We can click on this loan default, and we can see here, we'll just do a quick high-level statistical overview. We can see that it has member ID, loan amounts, annual income, maybe some delinquencies, and ultimately we come down to our target variable, which is a bad loan. So this is a binary class problem here. Very simple binary class problem. And so what we can do is once we have this information, we can come back here and we can go back to the data. We can maybe visualize it. We can use this auto visualization suite in Driverless, which is built by one of our chief product scientists, Leland Wilkinson. He is the author of Grammar of Graphics and really a pioneer in the visualization space going forward. So a lot of the work his team does is show data scientists, hey, I know you're putting this data into Driverless here. We ran through it and we found some interesting relationships here. Maybe you want to take a look at this, right? Just to be on the safe side, right? Maybe there's some spiky histograms, right? Maybe this makes sense. This could be fine, but we picked it up, okay? And if it's all good, then it's all good. If not, this allows the data scientist to say, okay, hey, wait a minute. Maybe there's something weird with my data set. Like for instance, in this public record, the majority of people are zeros, but we have some people here that are fives. We have one particular line here that is, or this particular person is one or is number 5. So is there something wrong with the data, or is this what is expected by the data scientists, right? So inspecting the data, visualizing the data, right? Making sure that all your steps will lead you to success are also very important. So now let's just go back to the data set and let's just build a quick model here. Come back over here, grab it and click on predict. And then Driverless will do a few things. Once I select my target column, Driverless makes some assumptions which we can completely override if we want to, right? But we can say, okay, I'm selecting bad loan as my target column. I have 39,000 rows for training, 19 columns. I might want to drop the IDs if I wanted to. I can do that here. If I have a test data set, I can provide that, or a validation data set, I can do that too. It's blinking area under the curve, so I'm going to say yes, we want to optimize for area under the curve. And then it gives me a couple of dials here, which I can play with. Accuracy, time, and interpretability. For today's discussion, we'll keep it super high level. All these numbers go from 1 to 10. The higher the number, the more Driverless does, the more or less things Driverless does to the model building. The higher the number of accuracy, the more performance building routines it puts onto your model or into your training set. The time deals with how much feature engineering works with Driverless. That is one of the big differentiators between our open source AutoML and Driverless. We have the built-in powerful suite of feature engineering here. The time deals with how long that works. And then the interpretability has to deal with the complexity of those features that are created, right? So let's just launch this experiment here. Kind of talk a little bit about what's going on before we go into the actual model ops deployment, and then we open it up to questions to the audience here. So what Driverless is doing right now is it's ingesting the data, it's starting to make some base models. It creates a base model that it tries to improve on. It'll say my base model will be, I don't know, 0.65, okay, 0.79 area under the curve with the features that you see here in the middle, and it has my ROC curve here. And now it's going to actually do parameter and feature tuning and model building, and it's going to try to build a better model that improves on the area under the curve here. And you can see here, there's a slight improvement. It found a different feature pipeline, trying different algorithms here. And now it's going to keep iterating, right? So this is like what I call the junior data scientist. You get a couple of driverless AI licenses, you give them to your data scientist, you get them to put the data in it, you let it run, and then you, at the end, inspect the results, right? You, at the very end, when all the projects are done, you get to inspect the results. And the way you do that is through our projects here. In this case, I have a very similar credit card, right, type of default one. And I have a couple of models here where I ran with different accuracies and different times and interpretability, and I can toggle on them and quickly compare them. I can review them and say, okay, how well did I do with area under the curve here? How good were they? Which is the best one? How did the features look like? You know, what did my confusion matrix look like? You know, how did my area under the curve look like? Things of all these nature that you would use to then evaluate which model is going to be put into production here, right? And how do you actually now put it into production? Well, that's the really easy part. Once you've actually built these models here, and you have model ops running, they are automatically deployed into model ops. So let's actually take a look at that now. And before I do that, let me actually now simulate some scoring data so we can see this in real time. I'm going to grab my project here. Over here, let me cancel out. Let me launch this guy. Here we go. Launch model ops and get a deployment here. Copy the endpoint URL and do this. Hit submit. Okay, excellent. So now let's just talk about this again. I have three different models over here, and I put them in a project, and the project automatically appears in the MLOps folder over here. I have a folder called projects. I have two projects. One of them is that credit card default. If I were to click on them, I can see what models are here. The one that's currently in production, this is one called Toronto Big Data. And I have a couple other ones which are not in production, right? So a lot of this is really the first gateway for the DevOps or data scientist, a person who's putting this into production here, is really getting the models over into deployment and then doing something with it. Right? So in this case, what we've done is we've gone here and taken this one model into production by coming over here and just saying, clicking on more details, you know, saying it's a single model. If I had another one that's in a different environment that maybe I could use as a champion challenger or A/B testing, we can definitely do that. But what we're going to do is we're going to monitor this data. We're going to monitor this particular model in production. And what happens is when this model actually goes into production, we got 1 second here. Let's come and take a look at it. What happens is the model ops product automatically spins up the model into a Kubernetes pod and exposes it as a REST API. And really that's what this, when I came over here and I did, and I came over here and I copied the endpoint URL, right? That's exactly what it is. So if I show a sample request here, I can quickly get all this information with all the fields here, right? So this is one of the easy ways of putting it into deployment, is really just putting it in driverless projects, and then it automatically shows up in MLOps, and then from there, promoting it into production, and then quickly getting your REST and API, REST points, your REST API endpoints, and so forth. And then it comes down to monitoring. You know, how good are you? How many samples are you collecting? You know, what does it look like for your balance, your histograms, and so forth, right? So that's really just a really super, super fast way of putting all these together, right? So once again, you have open source. You start with from open source. You can then work with Q. You can then work with driverless and then MLOps to put all these different things into various states of experimenting, production, and iterating over your data, right? So going, once again, learning all these different products, learning how we can fit into your various pipeline will actually kind of help you frame those questions, help you ask those questions a lot better. I'm going to pause here for just a second, and I'm going to stop sharing my screen, and I'm going to then flip it back over to the question and answering part of this thing here. So let me stop sharing my screen here. And let me go back to my slides. And now let's go do a Q&A.
Great. Thanks, Tom. So everybody, please start funneling your questions in. We do have plenty of time to go through as many of them as we can with time permitting. First question is, how much programming skills are needed mandatorily to become a data scientist?
So that's quite an interesting question. I started out actually with very little programming experience. When I went to engineering school, I learned Fortran, right? Fortran 77, and I promptly forgot that when I got out of school because, oh my God, it was Fortran. But don't get me wrong, and Fortran has its uses, of course. And I kind of started using a no-code platform in the early days of learning data science. And that really helped me because I was able to quickly learn, what cross-validation was, how to evaluate a model and so forth. But then as I progressed in my career as a data scientist, you just can't help but learn either, R or Python or both or something like that. And then having that mindset of building models in a let's say, a no-code type of platform allows you to understand how the pipeline is being built, right? Allows you to understand what you need to do for massaging data. Like, so what will happen is, let's say hypothetically, you use driverless AI and you're doing it all throughout the GUI and you're building models and so forth. Well, then the question comes, I need to change something in my data set. Oh, I can't do it in Excel. How do I do it? Oh, okay. I can use driverless's live code data recipe to hack something in Python real quick, right? And then you learn it. Then you begin to learn it. You go, oh, this is really cool. Oh, I can use Python. Oh, what happens if I try the open source, H2O? Can I actually use that then? And then you go, oh, this is really easy. With 2 lines of, code, I can write AutoML, right? So it kind of builds on yourself. So at the beginning, everybody's journey is going to be different, but you will probably end up knowing some coding at the end, right? That's really just how it is. Next question.
Great. Thanks, Tom. Next question is, what is best for data science, R or Python?
Oh my gosh, you're ready to start a fight. This is kind of like in my photography groups, like what is better, Canon or Nikon, right? It really comes down to what works best for you, right? If R is what you were taught and learned and your industry uses R, then by all means continue using R, right? There's our Spark R for big data. You can definitely use that with our Sparkling Water open source offering. You can use R with driverless AI. Focus on the tools that make you productive, right? Focus on the tools that help you get to that endpoint quicker, right? And if it's something that you're not familiar with, learn it, right? Kind of goes back to that success criteria that said always keep learning. Always keep learning, but always think about with the production in mind. So whatever works best for you. If your company uses R and that's what makes them productive, then go for it. If it's Python, my preference is Python because I have an engineering background. I just seem to like it better. Then, use whatever works. Use whatever works. Great question.
Awesome. Okay, next question. How can someone that doesn't have very good people skills develop these soft skills that you mentioned?
Ooh, that's a tough question, right? When you're in the tech world, especially in the data science industry, right? I could sit around a table with the Kaggle grandmasters at work here or other data scientists, and we could talk about, optimizing some loss function, and if anybody were to walk past us that is not in the field, they'd be like, "What are these people talking about?" Right? And so being able to bridge that gap to communicate, and this is perhaps one of the reasons why data scientists like to work with visualizations, because pictures do paint a good picture, or picture is worth 1,000 words. But it's really, how do you actually get your point across? Some ideas that have worked for me, and one of them that actually I owe quite a bit of my career to is learning public speaking. That perhaps if you can take a course in public speaking, maybe overcome some of your fears if you have fears of public speaking, that would actually help you be able to present better and be able to learn how to translate your technical prowess, so to speak, into more business acumen. Okay? Great question.
Okay, now this question's asking, will the notebook be available?
Yeah, I can make that notebook available, sure. Mm-hmm. I don't think there's anything bad in it, but yeah. Mm-hmm.
Right. And can I download H2O3 right now?
Yes, you can download H2O3 right now. It's a free library. You just go to h2o.ai and then look for H2O3, and then there's different. It's really a single jar file, and then you just download it and put it wherever Java is, and then once it spins up, it exposes an R and Python API.
All right. So this question might be a little off topic, but I think it's good to address. So for junior data scientists looking to augment their hard skill set, is there an opportunity to learn and practice with H2O products? I'm graduating this spring and would very much like to have these skills headed into my entry position.
Yes, we do offer, I believe it's called Aquarium, if you notice that there's a lot of water themes here. But we do have, there's an H2O community website that has a lot of information on it to help you in that case, and help you spin up, an H2O3 cluster on your machine. A single node cluster usually will be on your laptop or something like that. There'll be a lot of sample Python notebooks or R notebooks. There's a lot of available material to get you started with H2O3, which will definitely help you once you graduate. Yep, prepare you for graduation. Good luck. Next question.
Great. Let's see. So with data engineers automating data ingestion and data messaging, AutoML platforms tackling the problems of feature engineering and model selection, and DevOps putting models into production, where do you see the role of data scientists in the future? Will those duties be absorbed into other titles as the field of data science matures in corporate environments?
Very good question, and that's a tough thing. That's a tough one to answer. We all know that at the beginning, right? Data scientists, right? It's the hottest field out there right now, and going back to that image I shared before of the modern data scientist, it's almost like a unicorn. They have to be like everything. They have to be part DevOps, they have to be data scientists, they have to be part data engineer, and so forth. I think over time the roles of how the data lineage from start to end will probably begin to get a little bit more clear. I think that data engineers will arise, they have to almost be kind of like a data engineer / data scientist, right? Data engineer first, understanding what a data scientist may be looking for in the data, to massage the data in a way for the data scientist to consume. And then I think a data scientist might kind of quasi turn into a data scientist / DevOps person. Data scientist first, but having an understanding of what happens to their models after they're built and making it ready for the DevOps person. And I think there will always be a DevOps person that might have / a little bit of data science in them, a little bit of data engineer in them as well. I think the lines will become more clear over time, but I think you're also going to kind of have this cross-trained approach as well too, will probably remain in the industry for a very, very long time. that is a great question, and we could probably talk about that for a good hour after this presentation.
Absolutely. Okay, so this question's asking about H2O3. So is the H2O library free? Yes, it is. And then it's asking, how is it different from sklearn?
So that's a good question. sklearn there's a lot of similarities between H2O3 and sklearn. We have data scientists that use those libraries almost interchangeably. H2O3 is primarily focused on for big data. I know there's some things that you can do with sklearn. You can do different things with other things and so forth. But for H2O3, it's primarily focused on small and large data. It was designed from the ground up to be able to scale across clusters quickly. So that's probably the biggest difference there. But in the H2O3 library, splitting things into train and test sets, right? It's just called something differently in sklearn. Instead of using fit in sklearn, you use something else in H2O3. They're very, very similar. They're very, very similar. Yeah. Great question.
Okay. With H2O, can we use unsupervised models like k-means?
Yes, H2O3 comes with, I think, 3 or 4 unsupervised models. One is k-means. The other one was the isolation forest. And I believe general low-rank models, and maybe one more. I don't remember the fourth one, but 3 for sure. Yep. Mm-hmm. Mm-hmm.
Okay, great. Well, I think that about does it for the questions that we have here, and we're coming up on time. So I want to thank you, Tom, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined today as well. The presentation slides and the recording will be made available on our Bright Talk channel, and we hope that everyone has a great rest of their day.
Thank you all. Bye.